Hello everyone, welcome to Data Engineer YouTube channel. In this video, we will talk all about warehouse. We'll see with different types of schemas in warehouse. So what kind of schemas we can create using warehouse, and then we will practically see it in the fabric, right? So if you are new to my channel, you can subscribe it, and if you are not aware of what is warehouse, what is lakehouse, please do watch my previous videos. So we have created videos on warehouse, lakehouse, and then the difference between both of them. So do watch them before starting with this video. So firstly, we'll start with what are the different types of schemas we can have, or warehouse structures we can have, right? There can be three different types of warehouse structures which we can have. Number one is the simplest and easiest, which is the star schema. All right. So now, before starting with the structure, let me just tell you. So basically, if we talk about SQL or Azure SQL, you create tables in that, right? In any relational database, you create tables. Now, if we talk about tables, with respect to warehouse, there can be two types of tables. One is the dimension table, which we often call it as dim, and another is the fact table. Okay. Now, what's the difference between a dimension table and a fact table? Let's talk about sales. Okay, there is an e-commerce company which do some sales, right? So on each and every day they are doing some transactions. So we can consider the transaction as the fact table. So let's assume there is a table called transaction, which contains transactional data, and it is aggregatable, right? Now what I mean by aggregatable, like we can do some sum of the transaction, some product and so on, right? So I am assuming there is a e-commerce website, it's doing some transaction and they are recorded on a table called transaction, and we can consider it as a fact table, right? So this can be considered as a fact table. Now what can be the dimension? Okay, so let's say a person A ordered from, let's say, X location, or a person B ordered the product from Y location. So we can have one table called dim geography, right, which can be used as a dimension table. So it will tell at what particular location the person belongs to, right? And then there can be like time, right? Time dimension, at what time this transaction happened, right? And then there can be multiple factor, right? Maybe product, there can be different products in e-commerce website, so dim product. Now these are the different dimension tables we can have, right? So now the question is why we need why we can't have a one single table, and why we are breaking down the entire thing into fact and dimension tables. Reason being, we don't want to utilize a large amount of storage. Otherwise, if you will be using a single table, all the data, there will be a huge amount of data, and there will be redundancy, like duplicate records, right? Just the some value will be changing. So that's the reason we are going for schema structure. So now let's come to the star schema, right? So this is all about like what how warehouse works. So we generally have a dimension table, and then what we do is we usually have a fact table. So let me just quickly delete this, and let us focus on star schema. Alright, so now in star schema it says that we can have only one fact table. So in our, if we talk about that example only, so we can have fact transactions, and then we can have multiple dimension tables, time, and then we can have geography, and then we can have products, etc. Right? So now if you can see, it resembles like a star. So that's the reason it is known as star schema, right? So that is number one. Okay, so now let us see what are the different other types of schemas we have. Second schema is the snowflake schema. So let me just write the, let me just delete this, And let me just write down quickly about snowflake schema. Snowflake schema. Okay, now if we talk about snowflake schema, alright, so it's resemble as a star schema only, but dimension table further can be divided into multiple dimensions. For example, if we have fact as transaction and then we have time as a dimension, right, dim time. Now further time can be broken down into maybe dim months or dim year, right, like this. So a dimension table can be further broken down into multiple tables like that. So this is known as snowflake schema. You know, if a particular dimension table further we have more dimensions, that's known as snowflake schema, right? So generally, usually majority projects like star schema is very easy, right? It's very easy and less complicated, but generally as we grow, as the product grows, generally ultimately the star schema is sometimes may get converted into snowflake schema. So it depends, right? And it depends. Initially when you do modeling, you must ensure like what schema fits best to your product or anything, right? Whatever data you have, right? Now even dim geography can be divided into multiple tables. Maybe product is divided into multiple tables. Further, it is divided into multiple tables. So this is the structure of a snowflake schema. Please note, fact table remains same. One. Okay, we have one fact table here, and then we have the fact consonant schema. Okay, so let me just write it down. So third type of schema we have is fact consonant schema. Okay. Now, if we talk about fact consonant schema, it's nothing but star schema only. But what we can do is here we can have multiple star schema structures. For example, uh, this is one of the star schema for sales, right? Now, I have one more. Let me just copy this, copy, and let me try to delete this. Let me paste it somewhere here. Okay, all right. So now let's assume, let me rub this. So this is some another fact table. Let's say this fact is regarding, one of the fact is regarding transactions, maybe another fact is regarding product pricing. Okay, now we have two fact table, number 1, number 2, and they are also connected with each other. So this kind of schema is known as fact consonant schema, and it's very complex, right? So the operations we perform on fact consonant schema are very complex and time consuming. So we should generally avoid fact consonant schema, right? But obviously if it is required, definitely we can use it as well, right? Now let's go back to Fabric and let's see the modeling, how we can create a warehouse, how we can design a warehouse, and how we can use it in Power BI. So let's see it. So what I will do is I'll quickly create a basically I'll create a warehouse. So I'll click on warehouse, my dev warehouse, and I will click on create. It will take some time to create a warehouse. Now, if you're confused between a warehouse and a data lake, please watch the previous video. You will get the clarity between both of them. Alright. Now, one advantage of Fabric is because now we want to work with dummy data. I have a feature called sample data. I'll use that. And once I click on sample data, it will quickly create tables for me because I don't have as of now. It's a newly created warehouse, right? So let's wait for it to create tables for us, which will be the dummy data which we will be using, right? Okay, so it have created the table schema. It's copying the data. Let's wait for it. It may take few seconds. Alright, so basically our tables are created. So if you can see, there are multiple tables: state, geography, and so on. Okay, so let us recognize which is our fact table here. Okay, so we have weather data. So if you can see, this is the data related to weather. So date, geography, and temperature in Fahrenheit. We have something called trip. Is it the fact table? Let's see. Okay, so can you see in trip table we have date ID. Okay, we have Meladian ID, we have Hackney license ID, we have pickup time ID, drop off time ID, which is related to time, pickup geography ID, so it's related to geography. So see, this contains all the IDs which are different dimensions. So we can conclude this is our fact table, the trip one, right? Because using this table we can connect with each and every other table, right? And now we can easily create a star schema on top of it. How? So trip will be our fact table and others will be our dimension tables, right? Now let us see how we can create that. Okay, how we can basically create the semantic model where we will create relationships. Okay, let's do that. Now I will go to model. So if you can see, we have, these are the different tables which we have, right? Now what I need to do is I need to connect them. So can if we talk about the fact table, our fact table was let me just go back. Alright, so it was trip. So trip is our fact table. Let me just search for trip. Yeah, here it is. Okay, now what's the relationship between trip and weather? Okay, so there is a ID, right? So we need to create a relationship among both of this table. So how we can do that is, so weather is having date ID and geography ID, right? And here also we are having date ID and the geography ID. So let me create a relationship on geography ID. Okay, so just a moment. Maybe the drop of geography ID. Okay, and it will automatically detect, okay, it should be a many to one relationship. Cross filtering single. So if we see what's the meaning of cross filtering, let me tell you. Let me create this relation. Okay, so we have created this relation. Okay, I'm just assuming this data. Okay, so you need to do some analysis, okay, on which column you should create a relationship with. So this is many to one relationship, means many drop of geography IDs from trip table are connected to one geography ID of weather table. And there, if you can see the direction, so the slicing happens from weather table to trip table. Okay, so this is the slicing. Okay, slicing is from weather to trip table. So cross filter direction means if we apply a filter on weather table on the geography ID, what will happen is ultimately this fact table will get sliced, and it is the very perfect example. This is what ideally we should have in a star schema. And then we slowly we can even connect with other tables. So if we see, talk about medallion, so we saw medallion have a medallion ID, and here also we have medallion ID. So I'll create a relationship among medallion ID, right? And I'll press save. Now again, the medallion table is slicing the trip table, and it's a perfect relationship. Even it is basically by default it's sensing everything, but you can you want cross filter direction, definitely you can make it a bidirectional. Like, now your trip table can slice the medallion table, and medallion table can filter out the trip table, right? So this is how the things work. Now let's assume our warehouse is created. I'm not, obviously there are multiple tables. I'm not including them. I'm just considering this is our star schema. Two are the dimension tables and this is the fact table. And I can create a new report on top of it, right? So I'll not create the report, but yeah, you can create it. And now I know, okay, so if I, want to filter over the weather, I'll take the column from weather table, and ultimately if I, filter over weather, my trip table will automatically get filtered because we have a relationship, right? But if we filter over some other table which have no relationship, definitely it will not work. So this is how we generally design a warehouse. So let me recall everything what we did in today's session. In the starting, we learned what is basically a warehouse, right? We saw different, types of schema: star schema, snowflake schema, and then fact consonant schema. And then quickly we saw how we can create a warehouse in Fabric. That's all for today. I hope you enjoyed the video. Please do subscribe to my channel if you are new. These videos take a lot of R&D. Thank you, and we'll see you in next videos.